Okay. The sine rule is a relationship in trigonometry that is used to talk about the relationship between an angle and its opposite side. And that relationship is quite simple, that the proportion of the side to the opposite angle is going to be the same for everything in our triangle. I'm not going to go through the proof of it right now. We're just going to want to make sure that you can use it. And there's going to be three situations where it can be used: angle, angle, side, angle, inside, angle, side, angle. This one will be called the ambiguous case. So how does this work? Well, let's solve each of the triangles using the sine rule, show our setup, and we're going to give our answers to 3 decimal places. Okay, so if we look at this first one, we have this angle and that side opposite. So I'm simply going to write 3 over the sine of 16 degrees is going to be equal to, right? Well, we need to figure out this side length over here, right? And we'll call that x for now. So 3 over sine of 16 degrees is going to be equal to x over the sine of 72 degrees, okay? So if we look to then this next step, here's what we have. A cross multiplication, right? Multiply both sides here so that we can say that 3 sine of 72 degrees is equal to x sine of 16 degrees, which then would mean that x is going to be equal to 3 sine of 72 degrees all over the sine of 16 degrees. Okay, well, what's going to be that number to 3 decimal places approximately? Well, let's turn on our calculator here, and we'll come over. Let me put this where you can see most of the items. And if we look up my mode, we're going to want to be in degree mode. Okay, and so I have 3 sine of 72, right? But this is something that we can do to help us out also, right? Notice that here we see apps, right? Right over here we see apps, and I can hit second apps to get an angle. And I can always put an angle measure in there. So I have 3 sine 72 degrees, right? And it's going to be that number divided by the sine of 16 second apps degrees. And I have my answer, right, which is about, let's look at this, 10.35. Right, now we want to 3 decimal places, so that would be 10.351. Okay, now how could we do it in another way? The other way that we could have done this is if we knew that we were in degree mode, is set up our fraction 3 sine 72 all over the sine 16 when we get to our answer. And that's 3 decimal places. Okay. Now we'll say over here, it does say to solve each of the triangles. And generally when it says solve each of the triangles, it means to find all the sides and all the angles. So for right now, we're actually going to tell you just find a missing side. Okay, so we're going to try and keep things simple for you. All right, so right now just find a missing side. We found this missing side was x. Okay, so if we're going to do the next one, all right, if we're going to do the next one here, using the sine rule when we have angle, side, angle. Okay, well, I know this angle and this angle, but I don't know this side and I don't know that side, which means I need to figure out the angle right in here. What is the measure of that angle? Well, if you said 122 degrees, you would be correct. So how do we work with this? Well, this 122 degrees we know is opposite of the side with 4. All right. So what we can then straight off do here is to say that x all over the sine of 22 degrees must equal y over the sine of 36 degrees, which must equal 4 all over the sine of 122 degrees. All right, so what does that mean for us? That means for us that x then would be equal to 4 sine 22 degrees all over the sine of 122. And we could also figure out the value for y is going to be 4 sine 36 degrees all over the sine of 122. Okay, and sorry for the lack of space there. Of course, we could then put these into the calculator and find our values. Okay, so if we put these into our calculator and we look at the values, we see 1.767 and 2.772 for the value for x and the value for y. All right, so that's going to be 1.767 to 3 decimal places and 2.772. Now, technically speaking, right, our answers in each of these cases was in inches based on the units that we have. So over here, we would have inches, and over here, we would also have inches. Okay, and once again, when it says solve the triangle, it means to find all the missing information. So technically for this one, we did solve the triangle. We know all 3 angles, and we know all 3 sides. And it should make sense that 122 is across from the longest side, and 22 is across from the shortest side. Okay. Our last situation for the sine rule is called the ambiguous case. For the ambiguous case, the reason it's called ambiguous will become evident in this next situation. Okay, so if I look to here, okay, it says give my answer to 3 decimal places. Let's get this set up. All right, we have this angle, this side, and then we're going to have to play with the angle over here. Right, and I'm just going to go ahead and call that angle x. Right, so what can I say? I can say that 4 divided by the sine of x has to equal 6 divided by the sine of 34 degrees. Okay. Well, what does that mean for us further? That means for us that the sine of x is going to have to equal 4 sine of 34 degrees divided by 6. All right, which means that x is going to be approximately, well, if I use my calculator here, right, if I use my calculator, I say, hey, 4 sine 34 degrees divided by 6, right? Well, to get to x, I need to take the inverse sine of that number. So the inverse sine of that answer, right, is 21.8, right? Well, this right here, 21.8, would work for us, right? It would work for us because this angle is less than 34 degrees and this side is less than 6. So we'd say, hey, 21.888, the lucky 888 degrees. Okay, so that would be our missing angle, right? Now, if we know this angle, we know this angle, we of course can figure out the angle over here. And if I know this angle, then I can figure out this missing side line, right? Now, what would be this missing angle right here? Well, what do we know? This number plus 34 is 55. 180 minus that is 124. So this angle over here would be 124 degrees. Okay. Now, if this happened to give me a number, right? This happened to give me a number that was smaller than this angle, but I knew it needed to be larger than this angle. That's where we have this idea of the ambiguous case. And we'll study that in another video. Okay, so that's the sine rule. I'm going to use it to do a few problems, setting them up and getting them solved.